Hello boys and girls. In this particular video, I will be discussing your midterms for Algebra 2 for the following semester. And again, I know that the fact that you guys did have a teacher for so long, so what's going to be on this midterm is stuff that I have taught you. All right? And I'll also do everything I can to make sure that you are successful. All right, guys. This is what's going to be on your midterm. Complex number, transformational functions, factoring using the quadratic string method, 4 difference of squares and cubes, complex numbers and the quadratic formula, and solving equations, both quadratic and square roots. So let's go ahead and talk about the equations because I told you that I want two types of equations that we're going to be that you're going to be testing out. Square and square root. The reason why I want you to know these type of equations because when you graph them, they're essentially inverses of each other. Because going back to your 8th grade math, you know for a fact that the square root, I mean, the powers will take you back to earlier. Let me say this earlier, back to your elementary days. So you know that this is 2, right? Well, late elementary, middle school, sorry. But you learn from the fact that if you take the reciprocal of 2, it will be a half. So you know that. So that's what you plan to hear. Now get back to your 8th grade, you know that when you have a square root in the x side, this could be rewritten as x to a half power. So that's the reason why we are dealing with quadratic and square root functions or equations. So let's go ahead and do it. So one of the things that we learn how to do is this. We put in the standard form of quadratic. So you know for a fact you got 5 numbers when you multiply them together gives you 6, but when you add them together gives you 5. So 2 times 3 is 6, but 2 plus 3 equals 5. So you write it in factor form, x plus 2, x plus 3, set up to the equation, set to 0. You're going to realize you're going to have x equals, when you solve both of these, x equals -3 and -2. So that's one way of solving the quadratic equation standard form. But what about if I was giving it to you in the vertex form when we try to solve those equations? That's what we had to worry about next. So let's do 2 equals x minus 2 squared minus 2. So look, To solve this equation, of course the main goal of any equation is to get x by itself, but to do all that, so subtract 2, add 2, because remember, you gotta get x by itself, so what you do to one side, you do to both. 2 plus 2 is 4, x minus 2 square. Now, remember what I told you? Well, I'll say that for a second. To solve this, you see this square right there? You're going to take its reciprocal, and its reciprocal is half power, and you do 4 to the half power there. Essentially, the square root of 4 equals x minus 2. So, what's the square root of 4? It's just 2 equals x minus 2. So, alright, so let's finish this up. And remember, we're getting x by itself, so add 2 to both sides, add 2 right there, x equals 4. Voila, you have finished the equation. And of course, you can always check your work to make sure that you have a true solution. So let's see if the solution is true to this. So we shall say that equals 2. So 4 minus 2 squared minus 2. So 4 minus 2 is 2 squared minus 2 equals 2. So 4 minus 2, 2 equals 2. And that's is a true solution. Now, I probably won't ask you about true or false solutions till next semester because again, wasn't really taught to you. So, and next week's pretty much the test. So, I'd rather just do one more thing and just review. All right, so that's the square equation. Now let's do square root. Now the square root equations, they start with something like this: x plus 2 equals 4. This is what it starts off as. So to do this equation, so we know that's to be half a power, right? Well, the half a power is reciprocal is 2. So square both sides. You get x plus 2 equals 16. Subtract 2 from both sides. You get s equals 14. All right. And we like to check our solutions to make sure that we are true. So let's go ahead and rewrite and plug in. Again, this is checking my solution. So 14 plus 4, 16 equals 4. And the square root of 16 is actually 4. So therefore you are right. All right? Excellent. All right, complex numbers. Listen to me. So you're going to be left with A plus BI. Well, A is your real, and your I is your imaginary. The thing that you gotta know about your imaginary is this, that I squared equals -1. With that being said, let's get on with the operations of this. So let's do it. 3 plus 2i minus 7 plus 3i. So you know for a fact, distribute this, you get -7 minus 3i, and you get 3 plus 2i. So 3 minus 7, that's -4. -2 plus a -3i, that's just -i. Be careful with that. It's not going that I is not going to change to anything. Remember, that's going to be I squared. And you're going to mainly see that being dealt with multiplication and division. All right? So let's go ahead and erase. So we did addition and subtraction. Now let's do multiplication. All right? Use your for method. 3 times 3 is 9. 3 times -7i is -21i. 2i times 3 is -6i. Well, positive 6, that's no negative. There is no negative and that is positive. 2i times -7i is -14i squared, but remember, I squared is -1, so that could be rewritten as I rewrite this, 9. 21, -21 plus 6, that's a -15i. -1 times -14 is a +14. So 9 plus 14, so that's 23 minus 15i. And that's the simplistic way of doing it. That's just it. All right. Let's erase. So let's do division. So 3 plus 5 plus I. How do I do with a problem like that? Well, I can multiply by its conjugates. So the conjugates is going to be the opposite of the imaginary numbers. See how this was +1? Well, the opposite of that, or its conjugate, is going to be the -i. All right. With that being said, whatever you do in the denominator, you gotta do the same thing in the numerator. So let's do this using our for method. So you get 25 minus 5i plus 5i minus I squared. Well, that simplifies to, remember, -I squared. Well, I squared is -1, but because you deal with the -I squared, that becomes a positive. So that's just 25 plus 1, which is 26, in your denominator. So I'm going to erase this. 3 times 5 minus I. 3 times 5 is 15. And 3 times negative I is just negative 3I. And that's how you do those operations. Wonderful. So look, going further in the class, I was telling you something about that would have a negative square root. So say like you have a negative square root of 6, well 36. That can happen. That's no such thing as a negative. So as a result, this becomes I square root of 36, which is just 6I. Well, yeah, 6I. And that's, you're going to see that dealing with the quadratic formula next, or whenever I get to it. All right, quadratic transformations. So look, it's very important to pay attention to these things. So this pretty much tell you how to do all of that. All right. So just watch this, pay attention to it. All right. So here's an example of what I would do like on a test. I will give you something that looks like this. So let's look at it. So the x squared is the original, and the 1/2 x is the transformation. I want you to describe that transformation. And you should say, oh, it's vertically compressed. So it's compressed means smush, condense on the y-axis. So as a result, it's wider. So you could just say that. And again, look back at the previous state that talk about all about the characteristics of the quadratic functions. So, what if I was to give you something like this? I want you to describe that transformation for me. So it went up 1, it went right 3, and stretch on y by 2. And if it stretches, because it's a whole number, that means that it's, thin, because you pulling it, you stretching it. All right. All right, guys, quadratic formula time. All right, let's do this. So y'all ready? X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Quadratic formula solve. So look, remember b squared minus 4ac. If it's greater than 0, you got two solutions. If b squared minus 4ac equals 0, you get one solution. And then if it's b squared minus 4ac is less than 0, you get imaginary. Alright? So remember those three cases inside of this guy here. Alright? So let me erase all this. Let's go ahead and work this out. So x squared minus 2x minus 3. Alright? So remember ax squared plus bx plus c. That's the standard form where a and b and c are numbers. So a is 1, b is negative 2, and c is negative 3. Alright, are y'all ready? So x equals the opposite of the b plus or minus the square root b squared minus 4a c all over 2a. Alright, y'all ready? So again, let's work inside of the square root. So negative 2 squared, which we realize is going to be a positive 4. Alright, so let's do it. So I told you, and I'm working inside the parentheses. I mean the square root. So that's 4 squared minus, oh, that's actually 4 minus 12. Alright. So look, two negatives makes that a positive right there. So inside the square root is going to be 16. And we know the square root of 16 is 4, right? So let's put this together. So 2 plus 4 over 2. That's 3. And remember, there's always two versions of this because since we had a positive 4, I mean a positive 16 in the square root, that means somebody have more than one solution. So plus minus 4 over 2. So 2 minus 4 is negative 2, right? Negative 2 divided by negative 2 is positive 1. That's your final answer. So again, have the inside of that parentheses will have been And inside this square root, I gotta click on the parentheses. Oh, sorry. Have the inside the square root would have been like a 0 or a negative number, then you would have either one solution or imaginary numbers because and no such thing as a negative square root. So you will be dealing with something like that. All right. So I would do another one, but we do more practice of this in class. But I just want to see how you use the quadratic formula. All right. Difference of squares. So difference of squares, it's not that hard of a technique. You just have to write it. So difference of squares is just another way of writing factors. So you got x squared minus 16, right? So to write this, you're going to write this as x plus 4 with the parentheses and x minus 4 because when you forward this out, you're going to get x squared plus 4x minus 4x minus 16, and those cancel out, leaving you with x squared minus 16. So that was easy. So how about, oh, I'm sorry, y'all. Got a little bit distracted. So eventually, so that's how you have to really do with that. And we're going to do more of that in the classroom. So I'm going to go ahead and get rid of that extra x. Well, I could do another one. So what about x squared minus 81? X plus 9 and x minus 9. Alright? Simply just like that. Right? Difference of cubes. Alright. So difference of cubes is going to things like this. 5 cubed be 125 and things like that. So let's do it. X cubed plus 125. To write this, well, actually, that's the sum of cubes. But I'll do this one. So it's going to be x plus 5 times x squared minus 5x plus 25. That's how you write it. So that's the sum. Now let's talk about the difference of all that. Minus 64. Well, x cubed. So that's x minus 4. Because I know you want to say x squared, but unfortunately, that's not going to be the case. So that's essentially 4 cubed. 4 cubed is going to give you that 64. So x minus 4 x squared plus 4x plus 16. So you're going to do it just like that. And those are two things you will see on your test for sure.